Okay, let's take a dive into consumer preferences and budget constraints and consumer behavior in general. What we're doing is going down from the market level of demand to the individual consumer. And we're trying to build up a theory of consumer choice. Why does the consumer buy what he or she buys? And to do that, we need two pieces. With supply and demand, we had a demand curve and a supply curve. They were completely different from one another, right? The supply curve came from firms making decisions about how much of a particular good to bring to the market at different prices. That was the supply curve. Demand curve was all about consumers and what amounts of a particular commodity they were interested in buying at different prices, right? So they were totally different sides of the market. The market brought them together, and their interaction produced some market level equilibrium, price and quantity. So we're bringing two things together in focusing on consumer behavior. One is a budget constraint. This is really what's possible in terms of choices that you can make. The example here we're taking is tuna and bread, right? Quantity of tuna, let's say cans per week for an individual consumer, and bread is loaves per week. So we want to drill down into the possibilities to consume combinations of bread and tuna, and that's going to depend upon the prices of bread and tuna, and it's also going to depend upon income of the person. So budget constraints are all about what's possible in terms of purchasing combinations of two things, given prices and income. That's the budget constraint. And then, totally different, are these preference curves and difference curves is what they're called, that reflect consumer preferences. We'll have much less to say about where they come from and what their properties are. We make a minimal set of assumptions. Economists say there's no accounting for taste. So they're not interested in where preferences come from. They're assuming that they exist. We're assuming that they're following certain rules, axiomatic rules, and we're taking it from there, right? So that's a necessary part of consumer choice, but it's not a very interesting one for consumers, or for economists rather. On the other hand, budget constraints are much more important for economic analysis. It's all about prices and income, what's possible, and what things cost. And when we try to derive policy implications, the way to do it is usually to take the budget constraint and see how the budget constraint changes, right? And then we look at what the implications might be for a consumer's choice. We never ask about changing indifference curves because we're not equipped to say much about that. But there's a lot of action on the budget constraints, and that's really where the meat of the economic analysis comes from, and its ability to make predictions that we can test. All right, so let's start with the budget constraint with bread and tuna. Let's say the price for tuna is $1 a can. The price for bread is $3 a loaf, and we have $15 a week. So budget constraints are all about what's possible given income and prices. And what's possible with this combination of income and price are an ability to purchase with this $15, 15 cans of tuna, right? So this is going to be a point on the budget constraint. What about over here? Still the $15, but now bread is $3 a loaf. So the $15, you can buy 5 loaves. And you can buy combinations of tuna and bread reflected by the line in between these two endpoints. So we'll ignore the fact that you can't buy half a can of tuna, or half a loaf of bread, and just assume we've got some continuous function here. So there are properties of this budget constraint that we're interested in. One is the slope, right? Change in bread relative to cans of tuna. If we give up 1 loaf of bread, we can get 3 cans of tuna, right? 1 loaf of bread is $3. With that $3, we can buy 1 can of tuna, or 3 cans of tuna. So 1/3. And that's a measure of opportunity cost. A concept near and dear to economists. The opportunity cost of 1 loaf of bread is 3 cans of tuna. You could also say it's $3. And then the opportunity cost, let's say op cost of 1 can of tuna is 1/3 of a loaf of bread. Okay, so let's alternatively characterize this with an equation, right? So we've got bread equals 5. That's the intercept, right? Minus 1/3 tuna. So that's sometimes budget constraints are expressed that kind of way. This slope is reflecting opportunity cost, but notice slope is 1/3, but the price ratio of bread to tuna is 3-to-1. $3 to $1. So one thing to think about, why is the slope, which is 1/3, the reciprocal of the ratio of prices? Let me give you a chance to think about that. You would not need to spill the beans right away, would you? Okay, so I've cleared off the board and want to talk now about how changes in income and prices affect the budget constraint. This is the existing budget constraint. Suppose we have price of tuna going to $3, just like bread. Well, instead of being able to buy 15 cans of tuna with our $15, now we're down to 5 cans of tuna. There's a different slope. The slope is now 1-to-1 instead of 1-to-3. If, on the other hand, different color here. Red price goes from $3 to $1 per loaf. Now we're up to 15 and 15. So, I mean, this is pretty simple stuff. But what's important to think about is that the area under budget constraint is a measure of real income. Economists make a distinction between real and nominal income. Real income, in this case, is independent of prices, and it's actually showing what concrete combinations of, in this case, bread and tuna are possible by the level of income we're assuming here. So originally, the area under this orange budget constraint represented real income in the sense that a consumer of $15 could choose any point underneath this orange budget constraint, right? If they chose an interior point, they'd have money left over, but the area is reflecting all the possible combinations. If the price of tuna goes up to $15, that budget constraint is rotating toward the origin. And now, if you think about what's happened to real income, possibilities for buying combinations of bread and tuna have fallen. So real income has fallen. And by the same token, if we're going up to, or going down to $1 a loaf, we're getting this rotation of a budget constraint out away from the origin, which is going to reflect an increase in real income because the combinations of bread and tuna that are available have been expanded, right? So if the price falls, your ability to buy both bread and tuna have increased. That's the area underneath this curve. All right, so that's what happens when prices change. What happens when income changes? Suppose, let's take away the $3 a can and $1 a loaf, and ask if we're starting out, let's start out with the orange line we had before. What is going to happen to our budget constraint if we go from $15 to $30 per week? That's going to double the amount of tuna that we can get. I'm going to keep going out here. 20, 25, 30. And it's going to double the amount of bread that we can purchase. All right, so we could get 10 loaves with our $30 if the price stays at $3. And 30 cans of tuna if the price stays at $1 a can. And that gives us a parallel shift. Obviously, income is increasing because the area of possible combinations has increased. And this, even though I might not have drawn it very well, is a parallel shift in the budget constraint. So this 1/3 slope is still 1/3 because the relative prices haven't changed. But we're able to buy more of both, right? As reflected by this adjustment outward in the budget constraint. Okay, so what happens now? Let's put some erase in here. Let's double everything, right? Suppose tuna goes up to $2 per can. Bread prices double to $6 a loaf. And income doubles as well. Well, $30 per week with a price of $2 per can, it's still, we're still stuck at 15 cans of tuna, back to the original point. And the same way with bread, right? If bread goes up to $6, income also doubles. For $30, we're still back here at 5. Right? So the budget constraint hasn't changed. And the possibilities for buying combinations of tuna and bread haven't changed. We haven't brought in preferences yet, but you'd expect from this kind of simple analysis that if we were living in a time of inflation and I mean serious inflation, and over the course of a year prices doubled, but if at the same time incomes doubled, you'd expect people to be just as happy because they haven't faced any change in what their real income is. They can still buy this kind of combination of numbers of loaves of bread and numbers of cans of tuna. It never turns out that way. People are much more sensitive to inflation, as we've seen in the last few years. Probably had a huge effect on the election. People were certainly noticing the higher prices. It turns out since the pandemic, there's been, I'll talk about this in a later class, but there's been a big increase in real income, particularly for wages, for workers with low wages. It's kind of a reversal of what we talked about in the very first class. And no one is talking about how they have more income now than they used to. You're only talking about how the fact that gasoline is more expensive now, or eggs are more expensive now. So, you know, economics doesn't do a great job with dealing with these kind of predictions about differential perceptions of on the price changes and income changes. But the basic theory would say if that happens, if it's doubling, you wouldn't expect people to be grumbling about it. They're not making progress. They're not able to buy more cans of tuna and loaves of bread, but they haven't lost any of those possibilities either. Okay, so I've changed things up a bit here to show how consumer theory can be more generalized to things that you might not think were obvious. And one of these areas that we're going to spend a few weeks on is a choice of how much to work, right? And that might seem like it doesn't belong with bread and tuna. But in fact, the kind of tools that we develop for traditional kind of consumer choice fit well in understanding labor supply choices. So what we have here is quantity and price. But the quantity is work hours per week. And we're drawing a reverse kind of scale for this. So this is 0 hours of work per week, 20 hours of work, and 40 hours of work. And we do this because it's traditional to put goods and not bads on the axes. So higher amounts of things on the x-axis are better and better, and on the y-axis, higher amounts of better and better too. So you can really think of this as leisure, in other words, non-work, running out in this direction, and then work running back in this direction. We'll see how this is useful soon. But if work is bad and leisure is good, then we want to have work be increasing as we go left. So we have the 0 hours per week, 20 hours a week, and 40 hours a week. And earnings are going to be a direct result of the work hour decision. So suppose we face a price, a wage rate of $5 an hour. If we don't work at all, our earnings are 0. So that is a point on the budget constraint. If we work 40 hours a week at $5 an hour, we're going to be here at $200 per week. So in the same way that we could look at combinations of bread and tuna that used up our budget constraint, we can look at combinations of work hours and earnings that are possible for us at a $5 per hour wage, right? So that's determining the slope, and 0, and in this case 200 points corresponding to 40 hours a week. If we ran this out to 60 hours, we'd be making more. But it fits into the budget constraint framework. And what's nice about this is that it enables us to bring in a complication to a budget constraint that isn't just, raising a price from $1 to $3. Suppose the price goes up. Suppose wage is $10 per hour for all hours greater than 30. All right, so it's an overtime, double time for overtime. And the limit on when overtime starts isn't 40 hours, but suppose it's 30 hours per week. Now, as I say, the trick in applying this consumer choice is usually properly understanding what happens to the budget constraint. How does budget constraint change to accommodate this overtime? Up until 30 hours, nothing's changed. It's only beyond 30. And how is it going to change? Well, at 30, we're making 30 times 5 or $150. And if we go from 30 to 40, we're going to be making $10 per hour. Can you sneeze here? I guess not. So then we're going to make $10 per hour times the 10 extra hours, so $100 more. So instead of 150, we're going to be up to 250. So the budget constraint is going to have a kink at $30 an hour, and it's going to reflect the fact that this extra higher price for overtime work is expanding our consumption possibilities, our leisure possibilities, and earnings possibilities, as reflected by the new portion of the budget constraint. So that's going to be important if we want to make predictions about how this is going to affect work. And then we have to bring preferences in for that. But we'll be able to understand the circumstances under which this isn't going to affect amount of work at all, or for some people, it's going to cause them to work more. So we'll get to that once we bring in the indifference curves. So let me set up the indifference curve. Let's move over to the preferences side. As I say, this is part of the theory that's built up with minimal assumptions. And the basic assumptions are more is better, completeness, and transitivity. More is better, if we're again back to the tuna and bread world, and presented with combinations of cans of tuna and loaves of bread. Let's say A and B. All that we ask of the consumer is, if I give you these two possibilities, which do you prefer? Or are you equally satisfied with them? And one of the assumptions is that more is better. That if you're presented with B instead of A, that represents both more bread, more tuna, and more is better is assuming that someone is going to, somebody's trying to break in. Somebody's going to prefer B to A because B is more of both. Aaron Ainsworth walking down the hall. Okay. So we talked in the labor leisure choice of having goods go out in the positive direction. And it's just a convention, and it simplifies things to have things go out in the positive direction. And in that sense, more is better makes sense. If, on the other hand, we present a consumer with A and B prime, there's kind of a trade-off here, right? We've got less bread, but more tuna. So you can't really say a priori that a consumer is going to choose B prime over A in the way that we could be pretty confident. If these were both goods, that a consumer would prefer B to A. And the idea here is that is one of completeness, right? We could give a consumer all these possible choices, filling up the whole space, and the consumer would be able to say, yep, I prefer A to B, I prefer B to A, or they're equally preferred to me. So I'm not saying I'm indifferent to them right away, because indifferent has this connotation of, I don't give a damn. But that's not at all what consumers mean by that. Indifference just means equally preferred. So now we'll talk about indifference groups. That's completeness. And then transitivity is that if A is preferred to B and B is preferred to C, then A is preferred to C. It's a reasonable kind of assumption, and we'll invoke it on a couple of occasions. So let's keep going here. We've got these assumptions. And let's now think about indifference curves, where you've done this kind of exhaustive questioning of individual consumer. And let's say that if they have to choose between A, B, C, any combination of those, suppose that they happen to say for A and B, those are equally preferred to me. B and C, those are equally preferred from transitivity. A and C are equally preferred. And indeed, let's keep going and imagine all possible combinations of bread and tuna to which an individual consumer is indifferent in an economic sense. So this is an indifference curve. So slope, let's call it an IC. Slope of the IC, the indifference curve, reflects a consumer's willingness to give up bread for tuna in this case. Okay. So that's, at any point along here, you can look at the slope and see a willingness to give up, in this case, bread for tuna. That slope's changing. We'll talk about that in a minute. But we want to contrast this with what we talked about before, which was the budget constraint, right? That was usually a straight line. And that shows your ability to give up one good for another. Indifference curves are all about preferences, and it's your willingness to give up one for the other. So going back to these indifference curves, the slope is reflecting this willingness to give up one for the other. The economists call this the marginal rate of substitution. Bread for tuna. Right, that's the slope. Economists always like to come up with fancy words for things, and sometimes it doesn't make much sense. I mean, rate is already a slope, so marginal rate is kind of a slope, which doesn't make any sense. So some people have tried to reform the language and call this the rate of commodity substitution, but you've got to swallow your objection to the redundancy here and just go with MRS, marginal rate substitution. Now, if we have an indifference curve that's drawn like all the indifference curves in the book, you know, which is this kind of concave shape, convex to the origin. That is embodying certain preferences about what the marginal rate substitution is. Here, we're willing to give up a lot of bread to get a relatively small amount of tuna. As we get lower and lower on this indifference curve, our willingness to give up bread to get tuna declines, right? And that is called the diminishing rate. Of substitution. As in this case, X increases. Marginal substitution of X of Y for X as X increases. And what's the logic here? You know, if we're over here, we've got a lot of bread and not very much tuna, right? Tuna is relatively quite valuable. To us, we've got a lot of bread, so we're willing to give up a lot of it to get just one more can of tuna. Over here, in contrast, it's the opposite. We don't have much bread at all. We're in Tuna City, we're swimming in cans of tuna. So we're going to be very reluctant to give up a loaf of bread unless we get a lot of tuna in return. So that is the assumption here. And it's quite logical. The more you have of something, the more of it you are willing to give up. To get something else. That leads to indifference curves that are convex to the origin. Convex to the origin. Okay, so that's perfectly reasonable. The more you have of something, the more you're willing to give up to get something else. And to the extent that's true, then you're going to have these indifference curves have this curvature, they're not straight. In a way that's convex to the origin. Now you can play around with alternatives. Suppose two goods must be used in a strict proportion. Two sugar cubes per cup of tea. All right, so now we're in a world of sugar cubes and tea. Teacups, sugar cubes. So if we've got, let's say, 5 cups of tea per week and 10 sugar cubes per week, and we offer someone 5 cups of tea and 20 sugar cubes, they're going to throw 10 of them away. They're not going to be any better off. So they're going to be indifferent between 5 and 10 and 5 and 20. So this is going to go all the way up here. And by the same token, if they have to be used in strict combination, if I've got 10 sugar cubes per week, and you offer me 10 cups of tea, I'm going to throw 5 cups of tea away because I need this 2-to-1 proportion. So that's going to give a kind of a right angle to the indifference curve. This is called perfect complements. They have to be used in strict proportion. So the kind of curvature, this is pretty extreme, but you can imagine some indifference curves being relatively flat and some being quite U-shaped. On the other hand, suppose 2 goods are perfect substitutes for one another. What will the indifference curves look like there? Figure that one out for yourself. But these ideas about perfect complements, perfect substitutes, translate into the shape of the indifference curve. So we've got these preferences. We've got 2 goods. Let's go back to bread. loaves per week, cans per week. Let's say we've subjected a consumer to an interrogation about every point, every combination here. And we've gotten them to confess what their utility levels are. And this whole space is going to be covered by utility, going to be handled by preferences. And we can think about those as being expressed as different in difference curves. So this is a difference curve for utility level one. This is for utility level 2, a higher level of utility 3. Right, so you can really think of if there was a third dimension that reflected utility, and if utility could be measured in a cardinal kind of way, a number attached to them, that is not an assumption economists are willing to make. But you can kind of imagine a surface here rising out of the board, and we're taking slices of it at higher and higher levels of utility. And that gives us these indifference curves. So once we have a budget constraint here, we're always going to be able to find indifference curves that are either above that, below that, or are just tangent to it. And it's this point of tangency that is of greatest interest to economists. We start out with a budget constraint. We still have tuna and bread here. This is the budget constraint. Now we bring in the consumer preferences, and there'll be indifference curve that looks like that, indifference curve that looks like that. And there's going to be one one, two, three. There's going to be one that is just tangent to the budget constraint. And given the assumptions of what we've been talking about, we would expect a consumer to end up basing the income and prices that are inherent in the budget constraint, having these preferences. We want to be as high up as possible. And this indifference curve 2 is just touching the budget constraint, right? So it's representing combinations of tuna and bread in this case that are associated with the highest possible level of utility that a consumer could get facing these budget constraints. So this is the consumer equilibrium choice. Once they're at, let's say, 10 cans of tuna and 15 loaves of bread, we're dealing with different prices than we had before. There's no reason for a consumer to move from this 10-15 combination because they can't get to a better level of satisfaction. You can't get to a higher indifference curve. And at this point, the slope of the indifference curve, in other words, a marginal substitution, equals the slope of the budget constraint. Another way of thinking about this is that at equilibrium, the rate at which a consumer wants to substitute bread for tuna, in this case, is exactly equal to the rate at which the consumer can substitute bread for tuna. Right, this is just the same thing as saying the slopes are the same. Slope of the indifference curve is the rate at which a consumer wants to substitute one good for the other. And the budget constraint is showing the rate at which they can substitute one for the other. And you can say, well, suppose that kind of equality didn't hold, right? So let's say if this is point C, let's say, and this is up here at point A. At C, we have this equilibrium equal slope. At A, we don't, right? At A, the slopes aren't the same. And you should think about, what way aren't they the same? And how should that spur a consumer to make a change, to not have A be this point of maximum satisfaction given prices and income. So it's all about the rate at which a consumer wants to give up, in this case, bread for tuna, not being the same as the terms of trade given by the actual prices. So the bottom line, I'll give you the answer here. We'll have many chances to apply this, but the slope here is steeper, so the rate at which the consumer is willing to give up bread for tuna is going to be less than the rate at which they can, right? So they go ahead and do it. So they move along this budget constraint all the way down to point C, because as long as they're not on point C, they're at the point where this rate at which they want to and rate at which they can aren't the same. So they don't want that, and they go ahead in this case and push for more and more tuna and less bread. If you're down here at point D, you have the opposite kind of situation. They're not very willing to give up bread for tuna. And so that's different from the actual terms of trade, the slope of the budget constraint. So they're going to be wanting to move up along this budget constraint, giving up more and more, giving up cans of tuna to get more bread, because bread is relatively precious to them. Okay, so I think that is probably it. The problem set for this week will have a lot of applications. And it's a little bit dry without pushing yourself with questions to understand how this all works. So let's meet up again. And the room I have for Thursday at 3, whatever the time we agreed to is 3216 again. All right, so see you at 3216.